Hi friends, welcome back to the unit Power System Reliability. In last videos we have discussed the system reliability planning criteria for generation, transmission, distribution, grid reliability target. Today we are going to discuss security requirement. Security requirement. Power system reliability is the overall objective in power system design and operation. It includes two main aspects, adequacy and security. Outage and large blackout occurred more and more frequently than before during the last 30 years, which affected the normal consumption of consumers. The spotlighted our requirement to realize the complex phenomena related to power system and the development of emergency controls and restoration in order to meet the need of the power system security. A self-healing grid is needed to monitor and respond to the change within the whole network in time. Smart islanding is considered as an effective way to prevent small outage on the system from propagation into big blackout. With the increasing electrical power demand, electric power systems are operate closer to its stability limit. The operation of power system becomes more complicated and will become less secure. Power system security can be defined as the ability of the electric power system to withstand sudden disturbances such as electrical short circuit or unanticipated loss of system element without affecting delivering power to the customers. The objective of security analysis is to enhance the power system ability to run safely and operate economically. It relates to robustness of the system to implement disturbance and hence depend on the system operating condition as well as the contingent probability of disturbance. A power system is said to be operated in the normal state if the following conditions are met. There is a perfect balance between power generation and load demand. Consequently, the load flow equations are satisfied. The frequency is constant throughout the system. The bus voltage magnitude is within the prescribed limit. No power system component is to be overloaded. In the power system, the equipment are usually protected by the automatic devices which can make the equipment quit the system immediately once it operates out of its limits. The event may be followed by a series of further actions and cause other equipment disconnected from the system. This is called the cascading failures. If the process of cascading failure continues, then the system will suffer from blackout, which means the whole network of the most part of it may completely collapse. Thus, it is not sufficient to merely maintain a system in the normal operating state. We need to specify security for each system to withstand the disturbance under distinct conditions. The system security function. Even if we give a set of disturbances to a power system one at a time and it still can operate in the normal operating state, then the system is said to be secure. In practice, all power systems can avoid being affected by unpredictable fault and failures such as lightning strike on transmission line, mechanical failure in power plant, or fires in substation. In virtue that this nature phenomena are unavoidable and happens relatively frequently, all power systems should be designed to withstand from without emergency. In order to avoid blackout and wide-scale consumer disconnections, the system should be operated with a sufficient margin which can be explained in terms of two elements, reserve generation and transmission capacity. Reserve generation means leaving enough reserve generation capacity in case of loss of generating unit. Transmission capacity, keeping enough to transmission capacity to make the flow that was flowing on the outage of line. If we discuss the power system security function, the security system can be divided into three modes. First is the steady state security, which is created under the steady state condition of a power system. Transient security, which cope with the transient state of a system when it is subjected to a disturbance. Dynamic security, which concerns the system response of the order of few minutes. Usually, security function concerns three major aspects: system monitoring, contingency analysis, security constraint, optimal flow. The continuous updating information on the condition of the power system is given to the operator through system monitoring. Based on this, some quantities such as voltage, current, and power flow and the status of electrical equipment as circuit breaker and switches in every substation in a power system transmission network can be measured and monitored. In addition, further information on frequency generator unit, output and transformer tap position can be also gathered and transmitted back to the control center. By account of the complexity and of the task, the data will be processed by digital computer and then we arrange in a database which gives the chance for the operator to display the information on large display monitors. The computer can also identify the overload condition of or voltage violation by comparing the incoming information with the given limit and remind the operator of reaching in a time. In practice, supervisory control system is a system which allow operator to control circuit breaker and disconnect switches and transfer tap remotely are always combined with such system to create a new kind of system. This is what we call SCADA, Supervisory Control and Data Acquisition System. The SCADA system makes the real-time monitoring and correction to overload or out of limit voltage available. Commonly, a SCADA system is composed of three types of communication equipment: human machine interface, HMI, master terminal unit MTU, and the remote terminal unit RTU. Supervisory control and data acquisition system SCADA is a high-tech computer supervision and control of power system network. Demand for power is increasing very fast due to the continual improvement in quality of urban lifestyle as well as the expansion of industrial sector. To meet these challenges, the need for real-time SCADA system in any modern power system utility is indispensable. The direct benefit of a modern SCADA system are constant access to real-time picture of an entire network showing the power system voltage, frequency, supervision, monitoring, control of power in real time, optimal operation of power system generation and associated minimum of outage and faster restoration of the system in the event of grid disturbances. Improvement in the quality of supply through better control of frequency, voltage and other parameters. Less dependence on basic telephone system. The function of contingency analysis is aimed at dealing with the problem that happens within a short duration, since it occurs so quickly that no operator could take action in time. This is often how the cascading failure come out. In order to refrain from this, we need to implement the contingency analysis program into our operation computer to eliminate the troubles before they arise as much as possible. Online security analysis. The power system security analysis has three main goals: determination of most probable time of contingency, prediction of the impact on the whole system, identification of power control action to reduce the risk of failures. Thank you. In the next class, we will discuss the disaster management.